Assalamualaikum. Today our group will conduct the Metacentric height experiment. So the objective of the experiment is to identify the position of the metacentric of a floating body by determining its distance from the center of gravity. So the main outcome for this experiment has two. So yang first is locate the position of metacentral of a floating body, and then identify the metacentral location for adjustable position, traverse, weight, and based upon geometry and depth of emission. So for theoretical background is for static equilibrium, the puntun, the total weight W must be equal to the buoyancy force F, which act through the central buoyancy B, which is located the centroid of immense cross-section. When the puntun hits to a small angle, the metacentral is identified as the point of intersection between the line of action of the buoyancy force and the extent. For the stable equilibrium, M must be above G. Okay, for the problem statement, the students are required to conduct an experiment on determining the location of the metacentric and by determining its distance from the center of gravity, where the distance is known as the metacentric height. Students shall be able to use the technical data from the experiment or using their own measurement. Reading data from the experiment shall be converted to appropriate units and tabulate accordingly.
Assalamualaikum and hi, my name is Muhammad Prinya bin Herman Effendi. My student ID 2022-835-666. So I'll be talking about the apparatus for this metacentric height experiment. You will need a ruler to measure the height of the pontoon, the width of the pontoon, and the length of the pontoon. This is called the mass mast. This is used to determine the center of gravity of the pontoon. And this fine string with the weight is called the plumb bob to measure the degree of the angle that was dispersed. And this is a mast that called jockey. This is one that will be traversing through the pontoon to make sure that we got the certain degree that we needed. That's all for the apparatus, and thank you. So for the procedure, we'll be starting by measuring the pontoon. The pontoon dimension will be determined by this ruler, and we accurately measure the width of this pontoon, which is 20 cm by the width. The height of this pontoon is 7.5 cm. The length of the pontoon is 35 cm. So, the second step, we'll be measuring the weight of this jockey by using this electronic balancing weights. First off, we need to re-zero the balance and calculate the weight of this jockey, which is 304.9 grams. After that, we'll be measuring the weight of this pontoon. The weight of this pontoon is around 1,219.6 grams. So for the fourth step, we'll be fill up the sink and try to float this pontoon in it. So float the sink first. After we fill up the sink, we will try to measure the center of the gravity of this pontoon by using this fine string and plumb bob. Then we measure the height of this weight mass, which is around 33.5 centimeter for the center of the gravity. Then we put the pontoon in the sink and try to float it. Make sure the plumb bob not going around so much, and it must be in the middle at the zero. It is a 0 degree, as you can see in this video. And also the jockey will be in the middle because we do not want to traverse any weight yet. And after that, what we're trying to do is to traverse the jockey 2 centimeter to the left. Which what we will do is try to untie this jockey first and then move 2 centimeter to the left. Let the plumb bob try to stop first before we take the measurement of the degree of the angle that was dispersed. Which what we found here is around 4.5 degree for the angle. As you can see the degree scale below here, right? So it is around 4.4. Then repeat the same steps like before by traversing the jockey to the left by 2 centimeter again, and do the same thing on the right side also. Then to measure the depth of the sink pontoon, we need to calculate the depth of the pontoon that not sinking. And what we'll do here is take this ruler and goes to this side and measure the length that is not sinking, which is around 4.4 centimeter. To get the image depth, the height of this pontoon, which is 10 centimeter, minus by the depth of this pontoon that was not sinking. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Arif Najwan bin Irwan. My student ID is 2022478514. So next for the result, we have to tabulate the data for pontoon length L. The unit is M. Next pontoon width B. Next pontoon height D. And then next traversable mass. And next total weight W. Next center of gravity G. Then the last one is inverse depth DI. So for the pontoon length, we get 0.35. For the pontoon width 0.2. Pontoon height 0.075. Traversable mass 0.3037. Total weight 1.52 to 1. For the center of gravity G 0.11. For the inverse depth DI 0.02. And then next, for to get the Metacentric height GM, which is BM minus BG, we have to calculate BM first, which is IG over V. For the IG is equal to L times B over 3 over 12. We get 0.000233, and for the V equal to L times B times DI. We get 0.0014, and then IG over V we get 0.1664286, and then for the BG, which is Y we take from center of gravity 0.11. BG is equal to Y minus DI over 2, which is 0.1. So GM, which is calculate BM minus BG that we just have calculate, and then we get 0.0664286 meter. Then we put it on the table. Distance to left X, angle, and then GM. And then last one, we draw the graph for Metacentric height and angle of heel. Thank you.
Hi, my name is Shukman Hakim bin Ismail, and I want to conclude the outcome of the experiment. First of all, metacenter is the point of intersection of the buoyant force and the center of gravity. In order to verify the stability condition of an immersed body, it is necessary to locate its metacentric point. One of the conditions is that the center of the buoyancy and the center of the gravity are coincident, so the body is stable. It is indicated that the stability decreases with an increase in the metacentric point. The lower values of metacentric height result in larger least angle for similar displacement of transversal mass. And based on the experiment, the result follows the theory as expected. The traversable mass was changed individually from 0.02 until 0.08 meter to obtain different values of angle and metacentric height. Although it became unstable as the experiment carried on, but it was stable enough to produce a moment to counter the action as the metacenter increased. From the result obtained, a graph of metacentric height against angle of heel was drawn. It shows that the values of metacentric height increase with increase of angle of heel. So, there are possible sources of errors such as human error. This error of parallax when taking measurements, as well as the error due to inaccurate measuring equipment. In order to achieve a better accuracy in measurement, clearer reference points are needed on pontoon. Furthermore, when measuring the center of gravity, care must be taken to ensure that weight is completely balancing on the string and not being influenced by other factors. And for the conclusion, it is concluded that the position of metacenter of a floating body decrease as the distance from the center of gravity increase. This shows that the stability of a floating body also decrease. For a stable equilibrium, the metacentric height must be above of its center of gravity. The procedure of determination of metacentric height as well as application to the stability of floating bodies have been discussed. Next, the position of floating bodies metacenter has been discovered to decrease as the distance between its center of gravity and its metacenter increases. This shows that a floating body's stability lowers well. The metacenter height must be higher than the center of gravity for an equilibrium to be stable. Thank you.